Today we're going to be working on another Amazon's interview question. This is Leetcode question number 38, count and say. If you have been given this number 33222251, you need to sound it out from left to right. So you will find out that you have two threes, three twos, one five, and one one. And that's what you're going to be returning in the next stage. Two threes, three twos, one five, and one one. What they're gonna be, because we're gonna start with one and then we're gonna sound it out every single time, or count and say. So if you have been given 4, if it is 1, that is the base case, we're gonna be returning 1. If it is 2, we're gonna say 1 1. If it is 3, we're gonna say 2 1s. If it is 4, we're gonna say, so we talked about 2 1s, right? So you're gonna count and read 1 2 and 1 1. So you're gonna be returning 1 2 and 1 1. In terms of the algorithm, again, as we said, we're gonna start with the base case, and then every single time, so we're not doing anything fancy here. We're starting from the base case, and for n amount of time, we're gonna be using a helper function by initiating or initially sending our base case, which is 1, and whatever it returns, we're gonna assign that value to it. So the first time it's gonna return 1. When we are sending 1, it's gonna be returning 1 1. Then we're gonna be sending 1 1, and it's gonna be returning 2 1. Then we're gonna be sending 2 1, and it's gonna be returning 1 2 and 1 1. Again, if you have 1 in here, right, you're gonna create an like the string builder, read the first character, right, and the count is gonna start with 1, and then for I is equal to 1 to the length of that, right, if that string character keeps matching with the count, you're gonna keep incrementing the count, and if it does not, then you're gonna say that okay, you need to put that character and the count into. So first of all, we're gonna be putting the count. You can also say it from here, the count comes first, so that's gonna make it to the string builder, then the character C, and then in the end you're gonna say that this, now the C, the new character is that one, and we also need to reset the count, and then you're gonna be appending it to the string builder, returning it. If it is not making sense, let's just go through that. Let's take this example here. You are saying 3 3 2 2 2 5 and then 1. Our I is here, our count is equal to 1. We start from there, so our character is 3. So all we are saying, if that is the character, which it is because we just said it here, right? So 0th character is that, and the count is already 1. Now the first thing, you are initiating with I equals to 1, and you are checking if it is the same character. Yes, it is. So the count is gonna become equal to 2, and then nothing else is gonna be done. Then we're gonna go to the next one. Is that character is equal to this C character? No, it is not. In that case, we're gonna say that whatever you count you have, the count is 2, so 2, and whatever that character you have, which is 3, right, that is gonna be part of that result string builder, right? And you need to change this one to whatever the new character is, that will make it 2, and you need to make it set it back to 1. That's how we're gonna keep doing it, putting things in here, and that would give us the result. That's all I wanted to cover in this. Yeah, in terms of the complexity. Okay, in terms of the complexity, uh, it's a little bit tricky in the sense that look at this one. So initially you may think that if I send one as a string in here, I'm getting one as a string back. So next time 1 is becoming 1 1, then 1 1 is becoming 2 1, 2 1 is becoming 1 2 1 1. So what I'm trying to say is like maybe you may think that it is string keeps increasing, but that may not be the case, as look at this one where it's a long string here 3 3 2 2 2 5 1, which became 2 3, which became barely bigger than the previous string. So it is not like exponentially or by any easy mathematical formula, it's not actually changing like that. Also, another way of looking at it, so what I'm trying to say is like it is not okay. Let's look at it this way, that we have been told that n can go from 1 to 30, right? So everything is gonna be constant because we know at the most uh, we can actually have 30 iterations in order to get to any of those, right? um, yeah, another thing is normally the complexity is is seen when there is a like a there is a relationship between an input which we are getting and the output which we are doing, right? So but over here the input and the output are not that related, because the input is just telling us do 4 iterations, do 5 iterations, do 6 iterations, right? It's not actually the string which, or it is not telling us where to start from, right? So we can't really say it's O of n or something like that. But let's assume that instead of that number, or maybe there is anything like it is giving us an initial string which is 1 and a number, right? In that case, you can think of it that we're going to be going through 4 iterations, like, so it's basically what I'm trying to say is, let's say if the question would have been that n is equal to 4 and the initial string, the input string, is equal to 1, right? So let's think of that the input string as n and this one as x. You may say that uh, in that case the time complexity is nx. But basically at most it is linear. It is not like we are not doing anything other than uh, that, like we don't have multiple loops, like a loop within a loop. So yeah, at most I would say it's a linear. We are not using any extra space. Again we can think of it like maybe using O of n space, right? N being not what we have been given in the input, n being the length of the string, and then which is being sent to the helper function. So if you look at that, we do need an extra O of n space in order to save the result and send it back. That's all I wanted to cover in this video. Thanks for watching.